Welcome back to Logarithm Rules and to proofs first of all, because we've done a great job in the previous video. Sorry for I was interrupted and that's why I didn't finalize the video. So here we need to prove the last property and I'll show you a bit more like applications of those property on like given examples. So that's why I decided to split this video in two parts. So excuse me for that. All right. Let's try to prove the last property. Log with the base AB is log CB over log CA. So actually, I want to give some comments about that. That's my comments. So actually, you need to, this property is about how to choose a new base. You see that here and here, we have a new base C. And that's why you can freely move from base A to new base in this following manner. So that's why when we choose new base, we need to divide log with new base CB over log CA. Okay, and now we need to prove that. Okay, so how to prove? Let's see. Okay, so probably I'll do the following. Log CA, I'll just multiply both parts by log CA in order to have like linear form. I mean, not linear, but no with no fractions. And I'll get log CA times log AB. And on the right side, log CA will be cancelled. So we'll stay with log C of number B. Okay, so we need to prove that the left-hand side should be equal to the right-hand side, which is log CB. Okay. So what we're gonna do here, let me see, log CA times log AB. Oh, okay, so I found it. So let's try to use the property 5.1, which is this one. So one more time, I rewrite how it looks like, and it looks like that log, if we have, I just want to start from the right hand side. If we have some number p or some expression p times log ax, and we will get, according to the formula, log ax to the power of p. So simply the factor before log goes on the top. Okay, it goes on the top as the power. Can we apply that to the left hand side? Yeah, for sure, we can do that. Which way? I just simply say that this log AB is simply P. Okay, in our case it's P. So that's why what structure we will have? We'll have P times log CA. And now, according to property, we apply this property. It can be converted to the power for your number A. So A becomes in the power of P. And if we rewrite, because we have, instead of P, log AB, we'll get the following: log CA to the power, and the power represents log AB. So, okay, what we can do right now, we can do the following. If we have, remember the property, the main property for inverse function, A to the log AB, will have simply B left. Okay, that's, remember, we use that for inverse function when we try to prove in the previous video that's property, and here's actually highlighted there. Okay, so we use that, and now we just can come back and say that we have A to the power log AB is B, and hence instead of this expression we'll get log C, and instead of A log AB, we'll just have B in the end. Did we prove that that was left-hand side, LHS, of our equation? Did we prove that it's equal to right-hand side? Yes, we did, right? It's log CB equals to log CB. So now we can freely use all the properties from 1 to 6, and even some, outcomes like about inverse function and much more. And right now I'm going to give you some examples, like a real application, how we can apply logs. So I'll give you in the format GCSE, all right? I mean, not so complicated, so that you can do, all right? And let's say what we're going to have. Let's say we have log with the base 2 minus, let's say 1 over 2. Oh, okay, the number, yeah, of course. Log with the base 2, 5 minus 1 over 2 log with the base 2, let's say another number, maybe 25, and plus log 2, another number, let's take 7. Okay, so what we're gonna do here, we simply need to apply property by property and step by step to like some part of your expression. First of all, let's have a look. What actually you're doing? You have the main good way, the main good thing that you have here in this expression, and you have the base 2. So what are you gonna do with that? So simply calculate or like simplify. You can ask to make it simple. So make it simple. Simplify that. All right. So what we're gonna do? The main cool thing here about both logs have the base 2. So that's why, and you obviously subtracting, you adding. So what you can do, first of all, you can combine this log and this log together. So you're adding them, so using the property 3 for addition of log, from here you can come back to multiplication because of the base the same, so you simply put log 2 and 5 you multiply by 7. Okay. Next, you subtract 1 over 2, but it will be very cool stuff if 1 over 2 will be something as the power, so that you'll have pure log of 2, okay, log with base 2. So that's why we apply the property about powers. It's here. So actually we've applied the first property number 3 and the second property 5.1. So in this case we just simply count 1 over 2 as p, as power p, so we can lift it up and say that it's log with base 2, and 25 will be in the power of 1 over 2. Okay, so next step, log 2 with base 2 of 35, we subtract log 2, and remember the power 1 over 2 corresponds to square root of the number. So simply 25 square root is going to be 5 here. Okay, and when we do subtraction, now we apply another property about subtraction of logs. So hence you'll get the following. Finally, you'll get log 2. And using that property, you simply need to divide 35 by 5, which is going to be 7 in the end. So final simplified version is log 2 of 7. Okay? First is done. Let's see more like interesting example. Let's take another example, and it will be when we combine number and log. For example, you might have 5 plus log 2, let's say, let's take 3. Okay, so you need to also simplify that. Okay, what we're gonna do, instead of 5 we can apply log, and because we have log with the base 2, ideally we need to have the same log with the same base, log 2. So how to make from 5 log 2 of something? So we know just simply by definition log 2 of some value y should be equal to 5, right? Because the resultant of this is going to be 5. We have 5 here. So what we can do, we just simply need to raise, in order to find which y stays for, we just simply need to raise 2 to the power of 5. and that means it's 32. Okay, so instead of 5, we'll have log 2. So you may leave 32 or 2 to the power of 5. It doesn't mean like which way you do that. So I'll leave 32. And then I add log 2 of 3. Okay, so now I can use the property again about addition here. So how would I add them? I just simply leave log 2 and 32 I multiply by 3, so I'll get 96 here. Okay, of course, for sure you can calculate using calculator, but is the question about simplification without using calculator? That will be your final answer. Of course, if you can do if you can do it manually, it's good, but for manual like calculation, it should be something like this, for example. That will be 3. But in your case, you have 2 to the power of something equals 96. I guess you won't have such power, at least from the whole number set. Okay, so that was the second application, and let's try to do maybe much more interesting stuff. Let's zoom in and let's consider that one. So increase the font. All right. For example, you are given that P is log, let's say 3, 5, and you're also given like another number R, which is log, let's say 3, 8. Okay, so that's you're given. So you're given that means if you have that, you need to express in terms of pi and r the following. So what are you going to express? Let's say first we consider 3a log 340. Okay, so what it equals to in terms of p and r. So simply you need to write this log in terms of p and r. So on the right hand side there should be expression containing p and r. Okay, so what we're gonna do, we just simply need to apply the property, but our primary goal is to have those, like, let's say logs with the base of 3 and of the following like numbers 5 and 8. So hopefully we have 3 as the base, and that's how to get from 45 and 8. So we can simply say that log 340 can be written in the form log 3, and here is the way that you can do. You just simply use the property of multiplication, so factorize 40 by 2 factors. And now you understand that if we use the property 3 here about the sum and about the product of logs and of numbers, so we'll get the following: log with a base 3 of 5 and plus log with a base 3 of 8. Simply we apply the property, and now you know that this part is actually p and this part is r. So we mark this is p and this is r. So simply we'll get the following answer: p plus r. So instead of log 40, the answer will look like as p plus r. Okay, because we have them here, and this is the final answer. Okay, so what if you need to express, let's say, log of the division, like log 3, let's say probably let's say 32 over 25. Let's do that. Okay, so again, so that's 3b. Again, instead of log 3 32 and log 3 25, because you have division, you can use, first of all, because you want to have numbers 5 and 8. So first of all, you can actually split log 3 and 32 and 25. You can actually write as 2 to the power of 5. Yes, 32. Oh yeah, so that's not so good, but okay, maybe you'll switch them, I don't know. Okay, so instead of 25, what you can do? Yeah, 32 is not so cool, so maybe let's switch to 64. I guess it's impossible to solve that using like R and P purely. So we get 64 and 25. Okay, so how to cope with that one? So let's think one more time. How to make, instead of 64, obviously you need to get 8. So it's simply 8 to the power of 2, right? And what about 25? 25 is 5 squared, okay? What we're going to do now, we apply the property for division. So it means that property, x over y. How we can apply that? We simply make a subtraction of logs. So we simply subtract 2 logs of 8 squared, and we subtract log 3 of 5 squared. And finally, what you're gonna have here is log 2 log 3 8, using the property. Remember about power p, it goes like in front of, and here is the same, goes in front of. So we'll simply have 2 as a factor, and we subtract log 3 5, and power 2 goes in before like a factor. Okay, so simply we separate powers from numbers. Okay, and log 3 8 and log 3 5, so this is by definition, so you're given that one, right? And you can simply express or change log 3 8 is simply r, and log 3 5 is simply p. So your final solution is 2r minus 2p. Okay, that's how it looks like. So that one is simply log 2 log 3 8 minus 2 log 3 5, which is by exchanging back to r and p. In terms of r and p, we'll get 2r minus 2p. Okay, so that how it works. So guys, make sure you can deal with that property. You can apply, like you were shown like several examples, like 1 2 3, how to apply different properties. For more complicated properties, you'll find maybe somewhere else, like just go through past papers or go through like specific topic section, and so you'll get, for example, on my maths, right, you can get like more complicated questions. If you are not sure how to do that, just drop the comments. I'll always be able to give a feedback to them with like relevant answers or new video created. So make sure and feel free to communicate with me. So you're Daniel Dallas. Hope you enjoyed. See you later.